In this presentation, we'll discuss the issues and security risks surrounding legacy space systems and why we should either revamp or replace those existing systems to better protect ourselves from cyber attacks. Revamping legacy space systems is crucial for the future of space exploration. Outdated technology and cybersecurity vulnerabilities are pressing concerns. These systems suffer from cost inefficiencies, safety risk, slow development cycles, limited adaptability, environmental issues, and technological obsolescence. Legacy programs are expensive due to their complexity and outdated tech. Safety and environmental oversight can compromise missions and cause contamination. Slow development cycles can lead to missed technological advancements. Limited adaptability hampers innovation. Reliance on outdated equipment decreases reliability and efficiency. In a rapid evolving landscape, modernizing these systems is vital. By addressing these challenges, we can ensure that space exploration remains effective, safe, and sustainable, driving us towards new horizons of scientific discovery. In our exploration of the attack defense tree, we have taken a comprehensive approach to identify prevailing challenges within today's legacy systems. We have delineated 6 distinct subgroups that encapsulate the issues inherited to these systems: lack of software updates, unauthorized command injection, malware infection, communication interception, remote control exploitation, physical attacks, social engineering, insider threat, data tampering, systems eavesdropping. Each of these systems is linked to a standard cybersecurity defense mechanism capable of effectively countering the corresponding threat. By meticulously applying the appropriate updates to the legacy satellites, a substantial portion of these potential attacks can be mitigated. However, it is imperative to acknowledge that even with the limited implementation of updates in defense protocol, the possibility of counterattacks remains if the system remains incapable of receiving the requisite patches and updates.
It is also important to view some case studies and empirical evidence to show these attack vulnerabilities. In 2008, there was a breach in the Johnson Space Center Mission Control Network where hackers were able to upload malicious access programs onto the International Space Station computers. The root cause of this attack was due to the fact that these ISS computers were not receiving important software updates to their operating systems. So this just shows how unpatched and unupdated software can have detrimental effects for a system. In 2022, a more recent attack, there was the breach of the Viasat program. Threat actors were able to gain access to IP addresses, and they're able to exploit VPN vulnerabilities, which allowed access to the system. And this attack was also made possible due to misconfiguration and unpatched VPN appliances. There are often limitations that come with mitigation strategies. One of these is the lack of radiation-hardened electronics in the market. There are very few available options for new programs, and of those, there may be CVEs that are pre-existing and well-known by threat actors, as well as lack of computing power for these rad-hard electronics. And with that comes less processing space for modern-day security measures. Long program lead times is an issue as well. You may use the most up-to-date security features available at the time of program development, but by the time you launch, 5 years into the mission, these could be obsolete. As well as mitigation and defense strategies are expensive. It requires a coordinated effort across the program for these mitigation strategies to be implemented correctly. So finally, in conclusion, we've talked through how legacy systems contain many vulnerabilities due to unpatched or outdated software and components, older computing and processors that aren't able to run modern-day security features, as well as the use of COTS and open source components in software leading to highly exploitable features. These mitigation strategies are essential to maintain up-to-date security postures, applications of regular security patches, making sure that antivirus and malware software is fully up to date. These risk mitigation strategies must be implemented from a program development requirement space, and you must get the security professionals on board in the loop early in the system development process for this to work.